ठीक है. So we are doing the question that we have given as homework. So the second gas, what is the second gas? So the second gas that we can see is oxygen gas, and it is at a pressure of 2 atm and the volume is given 15 decimeter cube. So जो second gas है इस chamber में, this is oxygen gas, ठीक है? This is oxygen gas. The first gas was what? The first gas was nitrogen oxide. So let us write nitrogen oxide only, so that there is no confusion. Nitrogen oxide. Okay. All right, let it be. So the second gas is PO2. So it is pressure is 2 atm. Volume कितना होगा इसका? Volume of oxygen gas is 15 decimeter cube. 15 decimeter cube. ठीक है? So we have to apply addition law. Applying, they have asked you what is the final pressure if both of them, suppose इन दोनों के बीच में there is something, suppose there is two chambers and in the middle of the chamber there is this pipe is there, this black color, this is a pipe, and there is some knob. If you open the knob, then it becomes open, both the gas mixture can mix, both the gases can mix. Okay, so if I open this, suppose इसको मैं खोल दिया, like this is a knob, I just screw it open, ठीक है? तो क्या होगा? Gases of that both the chambers will come and they will mix up. समझ में आ रहा है? So applying addition law of gases, what do we get? We get total pressure P, total volume V is equal to P1 V1 plus P2 V2. तो यहाँ पे P1 किसको ले सकते हैं? PNO. वॉल्यूम किसको ले सकते हैं? VNO. प्रेशर N2 किसको लेंगे? प्रेशर P2 किसको लेंगे? PO2. वॉल्यूम 2 किसको लेंगे? VO2. So if we take the values, 3 times of 5 plus 2 times of 15, so it will give you a total of 45. PV is equal to 45. Okay, there is no unit right now. अब हम लोग लिखेंगे P is equal to 45 by V. What is the value of V? V क्या होता है? V1 plus V2. तो इन दोनों चेम्बर्स का वॉल्यूम कितना था? V1 is what? VNO. V2 is what? VO2. The volume of the chamber was 5 plus 15. ये हो गया तुम्हारा 20 डेसीमीटर क्यूब, ठीक है? So therefore finally जो प्रेशर होगा that will be 45 divided by 20, that will give you somewhere around कितना होगा? How much? 5 4 जा 20, 5 9 जा 45, it will be 4.25 atm. Okay, 4.25 atm. So this is the total pressure when both the gases mix up. इसको कहते हैं addition law, and the questions can be as simple as this one. Okay, so solution is done. So answer is your 4.25 atm. Clear? If there is any confusion, you must let me know. Next, Dalton's law of partial pressure. Very important law. ठीक है? Very important. Yes, you want to say something? Dalton's law of partial pressure. Okay, so we have taken a chamber. ठीक है? Chamber के अंदर क्या है? Chamber के अंदर there are two different types of gas, for example. ठीक है? There are two different types of gas inside the chamber. One chamber मतलब fixed, not a cylinder piston, but a chamber. Okay. So there are two different types of gas. One is this white gas molecules, and the other is the red gas molecules. ठीक है? There are two different types of gas molecules. ठीक है? Suppose in this room there are so many different types of gases. Oxygen है जो हम लोग ले रहे हैं, कार्बन डाइऑक्साइड है जो हम लोग छोड़ रहे हैं, हाइड्रोजन আছে কিবা আৰু বেলেগ বেলেগ গ্যাস হ'ব পাৰে, নাইট্ৰজেন, most of the air is composed of nitrogen. So the total air pressure is actually the sum of all the individual pressure of the gases. ठीक है, the total gas pressure এটো ৰুমৰ যদি total gas pressure টো ওলোৱা যায় তেনেহলে কি ওলাব, like it will be equal to the individual sum of pressures of all the gases. So ইয়াতে দুইটা গ্যাস আমি দিলো, এটা হল this white gas and the other is the red gas. Okay, so let this white be molecule A and let this red be molecule B. ठीक है, so molecule A has pressure PA and molecule B has pressure PB. ठीक है, these are the individual pressure of the gas components. Okay, without gas আছে a gas or মানে like my two hands, one is having, let me call it A, let me call it B. So pressure exerted by A, pressure exerted by B, when we combine both of them that will give the total pressure. ठीक है, that will give you the total pressure. So total pressure of the gas PT is equal to the sum of the individual pressure of the gas. समझ में आ रहा है? PT is equal to sum of the individual pressure of the gas. ठीक है, so this individual pressure of the gas, this individual pressure of the gas is also known as partial pressure of gas. A individual pressure मतलब partial means something that belongs to A only. Partial pressure of gas A. PB की meaning हो partial pressure of gas B. Partial pressure of gas B. ठीक है सर? So total pressure is equal to individual pressure of A, individual pressure of B. All right, this is a very very important law. So please write up to here. Next part, Dalton's law of partial pressure. About coitive sentence to ki likha ase, it states that total pressure exerted by the mixture মানে মই A আৰু B লৈছো, একেলগে ৰাখিলে এটো mixture হল এক ধৰণৰ, of non-reactive, very very important, this line is very very important, non-reactive মানে if I take gas A and gas B, if they react কি হ'ব পাৰে চোৱা, তোমালোকে জানা that pressure is directly proportional, PV is equal to nRT জানে হবে, pressure depends on number of moles of the gas. Okay, suppose if A and B reacts to form AB, so this is 1 mole, this is 1 mole, total how many moles of gas are there? 2 moles. 1 mole of A is there, 1 mole of B is there, total how many moles? 2. If there is 2 moles of gas, then the pressure of the gas definitely depends on the number of moles of the gas. Correct? Pressure of the gas directly depends on number of moles of the gas. যদি number of moles increase হয় pressure টো বাঢ়িব, number of moles decrease হয় pressure টো কমিব. Am I clear? Now what happens is, if they both react, A and B, both of them react to form AB, then what they will create is 1 mole only. So suddenly your 1 mole of A, 1 mole of B, that is total 2 moles, have combined to give you 1 mole only. Just they are giving you 1 mole of gas. So now what will happen? 1 mole of gas, if there are 2 moles of gas, pressure will be whatever pressure is there. If there is only 1 mole of gas, the pressure will be reduced to half. Okay. So if they are reactive, then what may happen? The pressure may not be what you are expecting. The pressure may be lesser than that. Okay. All right. So the gases, motamoti jodi bujibo lage khali roughly, it should be non-reactive. Is equal to the sum means addition of partial pressure of individual gases. Partial pressure means individual pressure of gases. Is it okay? So this is our Dalton's law of partial pressure. Very, very important. Now there is something more. What is that something more? So when you take partial pressure of gas A is equal to mole fraction of A into total pressure of the gas. You can find partial pressure of gas A in this way also. You can write partial pressure of B is equal to mole fraction of B into total pressure of the gas mixture. What is PT? PT is total pressure of gas mixture. ठीक है, total pressure of gas mixture PT. So PA की है partial pressure of gas A, PB की है partial pressure of gas B, and PT, what is PT? It is the total pressure of the gases. Is it okay? So ultimately PA is equal to XA dot PT, PB is equal to XB dot PT. এতিয়া যদি তোমালোকে mole fraction কি হয় এটো নাজানা, let me tell you. Suppose again I'm drawing a chamber. There are two gases, like you know that there is gas A. Let the number of moles of A inside the chamber be Na. Let the number of moles. Na is what? Na is the number of moles of gas A. ठीक है? Let me take one more sample. Let me take one more sample, that is B. I'm taking one more sample of gas, that is B. This B is yes, this is B, and this B has NB number of moles. So NB is number of moles of gas B. Now if somebody says you what is the mole fraction of A, the mole fraction of A is actually number of moles of gas A divided by number of moles of gas A plus number of moles of gas B. ठीक है? Na plus Nb means total number of moles of gas. Na plus Nb का मतलब क्या होता है? It means that the total number of moles of the gas molecules is Na plus Nb. Total number of moles of gas. Okay, total number of moles of gas. This is Na plus Nb. XB, अगर XB निकालना हो तो क्या लिखें हम लोग? XB is number of moles of gas B divided by number of moles of A plus number of moles of B. ठीक है? So Na plus Nb means total number of moles of gas. Na is specifically number of moles of gas A, Nb is specifically number of moles of gas B. Therefore, XA plus XB is equal to कितना हो जाएगा? It will be, if I write Na divided by Na plus Nb plus Nb divided by Na plus Nb. Let us take the LCM. Both have the same value, Na plus Nb in the denominator. Okay, let us take that, Na plus Nb. Then what will be the numerator? It will be Na plus Nb. ये Na आएगा ऊपर and this Nb will come bottom. Okay, Nb will come on the other part. Na plus Nb, Na plus Nb, it will get cancelled. ऊपर भी Na plus Nb है, नीचे भी Na plus Nb है, it will get cancelled, so the value will come 1. ठीक है? So the mole fraction, therefore the mole fraction Xa plus Xb gives you the value of 1. Very, very important. Very important. Dalton's law of partial pressure. This is here actually Dalton's law of partial pressure ends. These are the formula we might have to apply. This is not as important, but the partial pressure of gas we might have to find out. XA को कैसे निकाला जाता है, XB को कैसे निकाला जाता है, that we have explained here. Okay. If there is any confusion regarding that, you can tell me. Dalton's law of partial pressure, clear?
Yes, sir.
Okay. Next is Graham's law of diffusion. ठीक है? There is two words. दो word होता है. एक होता है effusion और दूसरा होता है diffusion. Effusion and diffusion. There is two different types of words. Effusion का मतलब क्या होता है? Suppose there is a chamber. When I use the word chamber, think it's a fixed volume. There is gas inside it. ठीक है? Gas molecules है अंदर. Now suppose there is a hole in the chamber. ठीक है? There is a hole in the chamber. तो ये hole होने से क्या हो जाएगा? The gas molecules will try to escape. ठीक है? The gas molecules will try to escape. क्या होता है? When you, if you suppose you have this DO with you, DO को थोड़ा सा हल्का दबाने से क्या हो जाता है? There will be an opening. अंदर pressure ज्यादा है, बाहर pressure कम है. So when the DO, you try to just press the, उसको क्या बोलते हैं? Whatever it is known as cap or something. Okay, key or something. When you press the key of the DO, then what happens? The gas comes out immediately. Why? Because the internal pressure increases and external pressure decreases. External pressure is less. Means हम लोग का बाहर में जो pressure है, that is less. So always remember, when we talk about gases, they flow from high pressure to low pressure. ठीक है? If there is same pressure inside outside, gas won't flow. ठीक है? Gas will not flow from a place where there pressure and the outside pressure is equal. So here, whatever is the pressure, outside pressure must be less. That's why gas is escaping, coming out. ठीक है? So this process of just leaking, leak हो रहा है ना? This is leaking. I give the example of Bhopal gas tragedy. This tragedy, the same process of diffusion happened. It's a gas which actually escaped, and because it escaped, it spread it all over. So diffusion का और एक जो word इसको दे सकते हैं, that is spreading all over. ठीक है? Spreading all over. And effusion जो होता है, that is like leaking out. This gas going out of the tiny hole outside ना, इस process को हम लोग बोलते हैं effusion. These gas molecules are coming out, and these gas molecules will be everywhere after some time. So this process is known as diffusion, spreading everywhere. ठीक है? Effusion means leaking out. ठीक है? Sometimes they might say you diffusion and effusion are similar. The words are similar, and it means similar things only. Sometimes the word diffusion may be replaced by the word effusion. ठीक है? इसमें एक ही बात है, यहाँ पे कुछ ज्यादा कुछ बोला नहीं गया. There is something very similar. या तो आपको मैंने पूछता क्वेश्चन. If there is two gas molecules, suppose I compare two gas molecules, One is heavier, heavy, the mass is more, and one is lighter. Okay, if there is two gas molecules, one is heavier and one is lighter, then the heavier gas, this is the heavier gas molecule, and this is the lighter gas molecule. Okay, lighter gas molecule. The heavier gas molecule will diffuse, will spread slowly, but the lighter gas will spread very, very fast. The lighter the gas, the faster it goes. Okay, there's a very famous story to that. On the left, there is a heavier person. Thus, the person is heavier. Okay, that's all. The person is, we are not trying to say anything else, but at least we must physically agree that it is, that the person must be heavier. And here there is definitely a sprinter. We have Usain Bolt's picture over here. So definitely he is more trained, but if he is lighter, then he can move faster. So there is a famous, you might watch this small cartoon is there about Usain Bolt, how he became the #1 racer. So there, like Usain Bolt as a child, he was running, like, but he could not win the race. So he was very upset and he was pressurizing himself. Like, I have to win, I have to win. Then his mother advises him, if you are so heavy up here, how will you run fast? Lighter you are, faster you run. Okay? So that from there, like the movie at least was shown like that. From there, his life changed. He started to be lighter and then he started to sprint faster. So the lighter you are, the faster you move. That is the concept. Okay. So this Gram's law of diffusion also says the same thing. When two gas molecules are spreading, who will spread faster? The gas which is lighter. ठीक है. I'm just fixing this cursor problem. The cursor, actually this yellow cursor, yellow hello that is around the cursor, that goes away because of some reason. I do not know why exactly. I'm trying to figure it out. Anyways, क्या हो जाएगा? Next क्या बोल रहे हैं हम लोग? Yes. So rate of diffusion, R, let R, this is R, represents a rate of diffusion. Okay. So rate of diffusion is given by rate of diffusion is inversely proportional to the square root of the molar mass of the gas. Okay. R is rate of diffusion, capital M is the molar mass of the gas molecule. Okay. Molar mass of the gas molecule. R is what? Rate of diffusion, and M is the molar mass of the gas molecule. So according to Gram's law, the rate of diffusion is inversely proportional to the molar mass of the gas. Molar mass of the gas. Clear? Square root of the molar mass of the gas. So if we compare two gases, gas A and gas B, like two gases, which will spread faster? For two different gases, rate of diffusion of the first gas divided by rate of diffusion for the second gas is equal to root over. Should I write the R in a different way so that you don't get confused? R, R, R. So it is inversely proportional to their molar mass. So R1 by R2 is equal to root over M2 by M1. Clear? R1 by R2 is equal to root over M2 by M1. So this is the formula for Gram's law of diffusion. This is the formula for Gram's law of diffusion. Okay. This formula is used to determine many things. Like for many different questions, we can use this formula. Okay, clear? Now, suppose there is another formula to find out rate of diffusion. Suppose there is a chamber, there is gas inside the chamber. So the rate of diffusion, R means the rate of diffusion. This R means rate of diffusion. Rate of diffusion is also given by वॉल्यूम ऑफ गैस एस्केप्ड आउट ऑफ द सिलेंडर. मतलब सिलेंडर के अंदर जितना गैस मॉलिक्यूल्स है वो अगर बाहर की तरफ निकल जाए, इफ इट गोस आउट, ठीक है, देन व्हाट इज द वॉल्यूम दैट हैज एस्केप्ड डिवाइडेड बाय इन हाउ मच टाइम दे हैव एस्केप्ड. ओके, सो V by T, where V represents volume of gas escaped, T represents time taken. It represents time taken. ठीक है. So R is equal to V by T. What is V? V is the volume of the gas that has escaped. T is time taken. Okay. So we have determined two different ways to find out the rate. One is the comparison R1 R2 M2 M1. ठीक है. Where R1 is the rate of diffusion of the first gas, R2 is the rate of diffusion of the second gas, M2 is molar mass of the second gas, M1 is molar mass of the first gas. तो ये दोनों रेट को हम लोग कंपेयर कर सकते हैं विद द बेसिस ऑफ देयर मोलर मास. ऑन द अदर हैंड we have R is equal to V by T, where V represents, this V represents volume of gas escaped, volume of gas escaped divided by time taken, volume of gas escaped divided by time taken. Is it all right? Clear? Let us take a question. One second. Okay. Okay. So there's a question. 25 ml of hydrogen gas takes 5 minutes to diffuse out of a vessel. How long will 40 ml of oxygen gas take to diffuse out of the same vessel at constant temperature and pressure? This is the question. 25 ml of hydrogen gas takes 5 minutes to diffuse out. Okay. So the rate of diffusion of hydrogen gas is 5 minutes. The rate of diffusion of hydrogen gas, we need to determine it. So what they have given is volume of the gas of hydrogen that escapes. Okay. So you will write solution volume of hydrogen gas, okay, is equal to 25 milliliter. Okay, 25 milliliter. So volume of hydrogen gas, you may write VH2. Okay, let me write well. volume of hydrogen gas is equal to 25 ml. Time taken T is equal to 5 minutes. Okay. Then volume of oxygen gas VO2 is equal to, okay, we don't need to find that, right? We need to just find the rate of diffusion of hydrogen gas. ठीक है? तो rate of diffusion of hydrogen gas को कैसे निकाले? Rate of diffusion of hydrogen gas is equal to volume of hydrogen gas divided by time taken. ठीक है? How much volume is escaping divided by the time that is taken by the gas to escape. So keep on at 25 divided by 5. That will give you 5 ml per minute. Done. Next, they have asked how long will 40 ml of oxygen gas take to diffuse out of the same vessel. Simple. So let us find out rate of hydrogen gas divided by rate of oxygen gas is equal to root over molar mass of hydrogen gas divided, molar mass of oxygen gas divided by molar mass of hydrogen gas. What is the rate? What is the molar mass? Molar mass of oxygen gas is 32. Molar mass of hydrogen gas is 2. Rate of hydrogen gas is, we have already determined, okay, rate of oxygen gas. So it will be RH2 RO2 is equal to root over 2 1 is 2, 2 16 is 32. So root over 16. Okay. So we have got root over 16. So what is the value? क्या हो जाएगा? Rate of hydrogen gas is equal to 4 times of rate of oxygen gas, because root over 16 is 4. So rate of hydrogen gas by 4 करने से क्या आएगा? Rate of oxygen gas, right? So rate of oxygen gas we need to find out. Rate of hydrogen gas कितना था? 5 divided by 4. Okay, this is the milliliter per minute. So we have to find out how long will it take. So rate of oxygen gas can be written as volume of oxygen gas released by time taken by oxygen gas, right? So 5 by 4 अगर हम लोग को लिखना है तो time of oxygen gas will be 4 by 5 times of volume of oxygen. Put the value, find the answer. What is the value? 50. ठीक है? So I'm writing it here, okay? Time taken by oxygen gas will be time taken by oxygen gas will be how much? 4 by 5 times of 8, 32. Okay, so it will be 32 minutes. So this is the answer to the question. Okay, so this is the answer to the question. 32 minutes. This is the total time taken for oxygen gas to escape. I hope this part is clear for most of you. Okay, let us try this question. Question पहले लिख लिया जाए. Pure hydrogen sulfide. Hydrogen sulfide is a gas. Okay, like water. H2O. वैसे ही होता है H2S. इसको कहते हैं हाइड्रोजन सल्फाइड. इसका स्मेल जो होता है इट इज लाइक ब्रोकन, लाइक इट इज लाइक रॉटन एग्स. ठीक है, एकदम बहुत ही गंदा स्मेल आता है इसका. स्टोर्ड इन अ टैंक ऑफ 100 लीटर कैपेसिटी, 100 लीटर कैपेसिटी at 20 degrees Celsius, 2 atmospheric pressure. The mass of the gas will be, तुमको क्या निकालना है? मास. गैस का मोलर मास कितना होगा? Just you have to find out that value. Please try to do that. Mass of molar mass नहीं निकालना, sorry. the mass. Mass means given weight. How much weight of the gas is taken? You can very easily find out. No issues. Please write the question first. I hope you have written the question. Just keep doing it. Take 2 minutes to complete it. Okay, let us start. Pure hydrogen sulfide is stored in a tank of 100 liter. So volume of gas is 100 liter. ठीक है? Temperature is 20 degrees Celsius. That is equal to 293 Kelvin. Just add 273 to convert it to Kelvin. Kelvin में convert करने के लिए सिर्फ हम लोग को 273 से add कर देना है. That's all. Pressure of the gas, how much? Pressure of the gas is 2 atm. Very simple. This is the volume, this is the temperature, and this is the pressure. ठीक है? हो गया. What is required? Weight is required. अच्छा, molar mass तो हम लोगों को खुद को ही निकालना पड़ेगा. Molecular mass. Molar mass will be किमान होगा? H2SO कारण है. H2. So hydrogen is 1, S is 32. So it is 1 times of 2 plus 32 times of 1. So if you add it, it comes to be 34 gram per mole. Very simple. तो पहले क्या करना है? Apply ideal gas equation. Applying ideal gas equation. What do you find out? PV is equal to nRT. So from PV is equal to nRT, you can write PV is equal to N को हम लोग क्या लिख सकते हैं? W by M. RT. We can write N as number of moles as W by M RT. So ultimately, what will be the thing? It will become W RT by M is equal to PV. Take everything on one side. W is equal to PMV RT. What is the value of P? P का value क्या हो जाएगा? P is pressure of the gas. What is the pressure of the gas? 2 atm. Molecular mass of the gas, that is 34. Volume of the gas kiman 100 liter. R is 0.0821. Temperature is 293 Kelvin. You need to solve it and you will get the weight of the gas. Okay, you just need to solve this question. Take everything in terms of letters and at last only put the numbers and don't try to put multiple steps. एक बार नंबर बिठा दिया, रफली कैलकुलेट करो, आंसर should be there. I'll just calculate it. 2 times of 34, 2 times of 34 into 100 divided by 293, ठीक है, divided by 0.0821. This gives you 282.68. 282.68 gram. Don't write gram per mole. ग्राम पर मोल सिर्फ मोलर मास के लिए लिखा जाता है, वेट के लिए कभी ग्राम पर मोल नहीं लिखा जाता. So weight of the gas taken is 282.68 gram. ठीक है? Is everything clear? Good enough. Okay. So I hope this part everybody has understood, and there should not be any confusion regarding that. Okay. Next question, next theory. Okay. The next theory is known as kinetic theory of gases, kinetic molecular theory of gases. Very simple theory, but very effective also at the same time. You should know this because all the gas more or less follows this theory. The first assumption, earlier assumption that was made was, if we take a chamber, suppose we have taken this chamber, ठीक है, हम लोगों ने क्या किया, एक चेंबर ले लिया, तो चेंबर में जितने सारे गैस मॉलिक्यूल्स होंगे, सपोज देयर आर सम गैस मॉलिक्यूल्स, ठीक है, let us take our cylinder piston system only, that will be better. ठीक है, this is our piston. ठीक है, so in the beginning there was a assumption that this gas molecule is there. Okay, this gas molecule is there. This is a gas molecule, and the volume of this gas molecule is so small, इतना ही छोटा है ये gas molecule, that their volume was neglected. Means if you want to know what space is available, okay, so if you want to know what space is available for this gas for its movement around, तो उसको कहा जाएगा कि उसका तो अपना वॉल्यूम है ही नहीं, so it can move all over. Just suppose I am in this room and I have a certain volume, ठीक है, मेरा कुछ वॉल्यूम है, but compared to this room my volume may be neglected. So वही गैस मॉलिक्यूल्स के साथ हो, that their gas molecules volume is so small, we all understand that gas molecules are very small, we cannot see them with our eyes, but they are not to be neglected always. अभी क्या किया गया, in the first theory they have neglected completely. उसको कहा गया कि हाँ वो बहुत ज्यादा, उसका कोई वॉल्यूम ही नहीं होता है, they are negligible, and that is why they are said to be highly compressible. Compressible का मतलब if two molecules have lot of space between them, then they can come very close as a sponge. Sponge क्या होता है, compressible होता है ना. Why it is known as compressible? If you take a sponge and you press it, it will become smaller and smaller until a point comes where you cannot press it anymore. ऐसा क्यों होता है, क्योंकि स्पॉन्ज के बीच में काफी ज्यादा एयर कैविटीज रहते हैं, right? There are a lot of air holes inside the sponge, and that's why you can press it. That is the reason for their compressibility. Okay, so compressibility actually কি হয়, compressibility মানে দুটা বস্তুৰ মাজত যেতিয়া বহুত স্পেস থাকে তেতিয়া তাক কি কৰা যায়, molecules বিলাক they can come very close to each other. As a result the space decreases between them, that is known as compressibility. ठीक है, so if the piston somehow comes down, যদি piston to তলৰ ফালে আহে, then what happens, the volume keeps on decreasing, inner volume will become decrease and decrease and decrease. As a result the molecule's volume, which was insignificant at one point of time, will now become significant. ठीक है, so এনেকুৱা হ'ব, and we will see it later, not now. Okay, so what will happen is this, suppose piston has came down to a level, the piston has came down to a level. Okay, the piston has came down to a level, and now the gas molecules have all come very close to each other. The gas molecules have all come very close to each other. Now the volume is available is so small that now you cannot say that it is very negligible, or the molecule's volume is negligible. ठीक है, अब उसका वॉल्यूम को हम लोग इग्नोर नहीं कर सकते, but for the moment we will say that because it was the initial, ठीक है, so they neglected gas molecule at all conditions. ठीक है, they neglected the volume of gas molecule at all conditions. So the first theory is the actual volume of the molecules of gases is negligible in comparison to the volume of empty spaces between them. Correct? So if you see the gas molecules, there are a lot of empty space between them, right? There is a lot of empty space between the gas molecules. These are the empty space between the gas molecules. तो ये empty space क्या है, बहुत ज्यादा है compared to this volume. Their own volume is very less. That is what they are trying to say. Compared to the volume of the molecules, the space, the volume of the empty spaces between them is also very high. ठीक है? That's why their personal volume is neglected. समझ में आ रहा है? Their personal volume is neglected, and that is the first hypothesis. The actual volume of the molecules of gases is negligible in comparison to the volume of empty spaces between them. They are considered as point masses. Point mass मतलब जिसका कोई volume ना हो. Okay. Point. See, there is how many axes are there? X axis, Y axis and Z axis होते हैं. 3 axis होते हैं. थोड़ा सा भी एक्सेस होगा तो उसका लेंथ होगा, थोड़ा सा भी वाई एक्सिस होगा तो उसका ब्रेथ होगा, थोड़ा सा भी जेड एक्सिस होगा तो उसका हाइट होगा. इफ यू डोंट हैव लेंथ आल्सो, ब्रेथ आल्सो, हाइट आल्सो, वेयर डू यू एंड इन द ग्राफ? यू एंड डायरेक्टली एट द सेंटर. ये सेंटर क्या है? दिस सेंटर इज ओनली नोन एज द पॉइंट, और इफ देयर इज अ समथिंग दैट हैज अ वेट, देन वी विल कॉल इट पॉइंट मास. इफ समथिंग इज देयर, दैट इज मास, पॉइंट मास. ठीक है? So center is known as the point mass. So if something does not have a volume, that is known as a point mass. समझ में आ रहा है? This assumption explains great compressibility of the gases. ये assumption से हम लोग को पता चलता है क्योंकि बहुत ज्यादा empty spaces है in between them, then they can be compressed. This is the theory for all gases, all everything. ठीक है? Suitcase भर रहे हैं तुम लोग. You are packing a suitcase before a holiday. तो क्या किया जा रहा है? पहले you are putting everything, stacking everything inside the suitcase. Then there are some more things and you think that you need to take a second suitcase for that. You need to take a second bag for that. ठीक है? तो वैसे करने से क्या होगा? You will be having 2 luggage with you. The burden will increase. But if you pack it well, because there is space in between, you may be able to compress, you may be able to adjust more things in one bag only. So this empty spaces are the reason why something can be compressed. There are a lot of empty spaces, and if you delete the empty spaces, anything will become compressed. ठीक है? I hope these things you are understanding. I don't know how many students are actually getting what I'm saying right now, but this is very important, and it is actually something very basic, very basic. सुनने में लगा है सर एक ही तो बात बता रहे हैं बार-बार, but this one thing is so important. If you want to do some research, you can do that. ठीक है? Let us move on for the next theory. Everybody, please write this, okay? I'll be also sharing the notes, but you write it. Better to do the class when the class is happening than seeing the recording. Recording में क्या होता है? There is no pressure, there is no force, there is nothing. Nobody is seeing you, nobody is right there. Okay, just you see it according to your own record. You can see it, it's a good thing. You can see it later, just for revision. There is no force of attraction between the particles of a gas at ordinary temperature and pressure. ठीक है? इसका क्या मतलब है? দুটা গ্যাস মলিকিউল if they are moving, they are doing some movement, দুটা গ্যাস মলিকিউলস মুভমেন্ট কৰি আছে। So suppose there is a wall, this according to this theory, they said that do not according to this theory they say that two molecules actually do not interact, मतलब अगर वो पास से भी गुजर जाए, they will not have any effect on the other, they will not attract or they will not repulse, nothing is going to happen. This is the theory, but in real life this is a wrong concept. When two gas molecules are passing, it holds a significant, like suppose a gas molecule is supposed to hit the wall, then if there is another gas molecule, it will pull it back, maybe because of there is some force of attraction, it will pull it back, and the intensity with which this molecule was supposed to strike the wall, it will hit the wall with a very lesser intensity because this molecule is pulling it back because of some force of attraction. ठीक है, रियल लाइफ में फोर्स ऑफ अट्रैक्शन एग्जिस्ट करता है और फोर्स ऑफ रिपल्शन एग्जिस्ट करता है. When there is two molecules, you cannot say that there is no force of interaction between them. There must be some force of interaction between them. That happens in reality, but this is ideal situation. Okay, this kinetic theory gas, ये जो kinetic molecular theory of gases है, it is not valid for real gases. They are valid for ideal gases. ठीक है, for ideal gas such things are mentioned. Okay, ideal gas is something that is not existing. Okay, ideal gas, real gas behaves as ideal gas. We'll discuss it little later, but we'll learn first what is real gas, what is ideal gas. Ideal gas मतलब ये सारा laws मान के चले, they are ideal gases. ठीक है. So according to this theory, if two molecules are even in very close proximity, मतलब बहुत सामने सामने हैं, लेकिन दोनों क्या करेगा, there will be no force of attraction, no force of repulsion between them. Is it all right? Clear?
Yes, sir.
Particles of gases are always at random motion. About this, I want to say something, that random motion means they are moving anywhere. If one molecule goes up, the other may go horizontally. Okay, the molecules may go anywhere, anytime. But the point is, when these gas molecules are moving, they are making a linear motion. They are moving in a line. Okay? They are moving in a line. So the gas particles are maintaining a linear motion. Okay, gas particles are maintaining a linear motion. So if the gas particles is going straight into the wall, then that is said to be having a linear motion. All right. Collision of gas molecules are perfectly elastic. What is perfectly elastic? One thing, gas particles are maintaining a linear motion. Linear motion मतलब क्या होता है? Linear मतलब होता है straight line. Okay, straight line. That means if there is two gas molecules, this gas molecule is there, it is moving always in a straight line, wherever it may move, left, right, here, there, but it shall move always in a straight line. Okay. Next, collision of gas molecule. This is the last thing that we'll do now. We'll do more about it later on. Collision of gas molecules are perfectly elastic. What is perfectly elastic? If two gas molecules ever collide, अगर दो gas molecules कभी भी collide करते हैं, then what will happen? अगर if two cars, suppose they collide, then there is a lot of sound and everything. The energy is lost in form of sound, heat, fire, so many things. The energy is lost. Okay. But when two particles of gas molecules collide, it is said that there is no loss of energy. There is no sound, there is no heat, there is nothing. No energy dissipated. कोई एनर्जी बाहर की तरफ नहीं निकलता. When suppose if two particles are clapping, see I'm clapping, so there is a sound at higher distance, the larger will be the amplitude of the sound. But if two particles, because that is the loss of energy that takes place, and this sound is an energy, and I do not know how it can be done, but it can be utilized or it can be converted into some other forms. ठीक है. लेकिन जब दो गैस पार्टिकल कोलाइड कर रहे हैं, when two gas particles are colliding, there is no loss of energy in any way. So if there is no loss of energy, suppose two cars comes and collides, there is no sound, no heat, no nothing, both cars are intact in their shape and everything. ठीक है. So that is said to be perfectly elastic because there is no loss of energy developed due to collision. Collision से loss of energy होता है real life में. But in this ideal situation, there is no loss of energy. ठीक है. So collision of gas particles are perfectly elastic. Perfectly elastic का मतलब होता है energy is conserved. Energy is conserved. Conserved मतलब loss ना करना. You have conserved water. That means you are not wasting water. So energy is conserved का मतलब energy waste नहीं किया जा रहा है. Okay. When the two particles are colliding, the energy is not wasted. So this is what we have done for today. We have done up to the kinetic theory of gases. Please study up to here. If there is any confusion, we'll see in the next class. Next class we are going to do very soon, and we'll do, now we have to plan more like how to take the classes on what times, so that because the situation is pretty not good. Okay, so that's why we are planning to shift it online only, tuition and everything. Okay, so all right, thank you for today.
Bye, sir.